What's up, everybody? My name is Archangel, and welcome to Universe Sandbox 2. Although it looks kind of like Universe Sandbox squared, but I am not going to judge. If you have not seen this game, calling it a game is kind of weird. It's sort of a simulation. It's just space. Ooh. And it's real cool. It's real cool. So I'm going at days a second right now. Time is flying by. So I'm going to knock that bad boy back to hours a second for just a second so we can take a look. That is still a little faster than I want. There we go. Minutes a second. You can see down here how many. Yeah, that's cool. So now you can see everything in glorious detail. You can see how much it brightens up my face too when I get close to the sun. Yeet. Okay. Alright. So this game is cool for a lot of reasons. And one of my favorite things about this game is it just lets you I don't know, just let you play around. So, like, for instance, this is our solar system, right? Here we are on the Earth, spinning around the solar system, going at 30 minutes per second. Just let you see that everything's still moving. No, it doesn't look like it, but we're moving pretty close to actual time, right? So here's our whole solar system, right? You know, you've got all the way out to Pluto out here, and then all the extrasolar bodies, the asteroids, the just the stellar debris, everything. Space has got a lot more stuff in it than you think it is. So I can just, you know, say add a black hole out here beyond the orbit of Pluto, and then that's what I'm talking about. Okay, so now you can see there went Mercury. You can see how all the gravity of the black hole, because it's 1,000,000 times the sun, the gravity of the black hole is pulling everything towards it, but it's still got the velocity it had before. So now we're going to add in a black hole that is 100 million suns. And there you go. Everything gets slung off into the universe. Because there goes the sun, and there's our black holes. Okay? Once you add in this just gigantic amount of mass with this 100 million sun black hole, and it just sends everything flying. Its acceleration vector is all over the place. It's crazy. Alright? But that is not why we're here. We're here because we want a simulation. Actually, instead of doing an empty sim, let's open an existing sim. And let's open up something nice and simple. Earth and Moon. Let's open up Earth and Moon sim, okay? So here's the Earth. There we all are. There's the Moon. Rocky terrestrial planet. Iron nickel core, thin atmosphere, nitrogen, oxygen, orbited by one moon. Sounds familiar. So here's what we're going to do. Let's see what we can do from space here. What we can do to this poor little blue planet. Yeah, little blue planet. Let's see what we can do. So first off, I can throw things at it. So there I put Deimos in orbit around the Earth, and I can put like several here, you know. And this is on minutes a second time scale, okay? About 45 minutes every second. So this is showing you how fast we're. Is that right? What it says. Yeah, that makes sense. So this is showing you at how fast things are orbiting. So I can put things in orbit like that, real nice, but that's not why we're here. So this is what I was looking for. So I can add materials. So let's say I add some hydrogen. We're not going to auto mass particles. We're going to throw 1 moon worth of particles at a rate of 100 particles per second of hydrogen, and we're going to throw it, and not at 10 kilometers per second. Let's throw it at 100. No, not 1,000. Let's throw it at 100 kilometers per second. So, and we made a gas giant, and we shattered the moons all around it. Okay, so Earth. Oh, I keep adding to it. Earth is now 1.57 Earths. Its radius is getting bigger. Its density is getting lower. Huh. And it's getting colder. That's interesting. Surface gravity, though, is staying the same. And it's picking up a little bit of speed. So what happened here is we made a gas giant, and because the mass did change, but just not a whole lot, the moon, well, it did change by a whole lot, but in terms of planetary scale, it only was about 50% more. So now what we're going to do, see, hydrogen, that's the fuel that makes stars burn. You fuse hydrogen into helium. So what happens if we add a whole bunch of hydrogen? Now keep in mind, every one of these particles is the weight of the moon, and I'm adding about 100 every second, and they're moving real fast. There, look at that. Look how much I increased the mass now that the moon is hurtling towards the Earth. It's negative 23 degrees Celsius. Picking up speed still. Oof. Now it's 878 degrees Celsius, and it's 22 Earths. But a density less than 1 gram per cubic centimeter. That's interesting. Huh. So, what if I add some iron? Oh yeah, there's, you can see the mass still going up. Oh, yeah, that's interesting. Density's going way up. So you can see that the size is not expanding really fast with adding this, but the density is going up really fast. So I'm going to get us up to about 1 gram per cubic centimeter. And right there. Okay. So now we're at a little over 1 gram per cubic centimeter of density. And because it's 877 degrees Celsius, all that iron is hot. And so it's glowing red hot like, you know, like iron does. Let's see what happens if I keep adding. Let's add some CO2. Okay, increasing the density but not changing the temperature. Okay, what about if I add some silicate? Okay, still increasing the density. We're at 76 Earths, by the way. Let's throw a little bit of water in there. Gonna get us up to, there we go, a little over 80 Earths. 81 Earths, 81 and a half. So we got decent density now. What can we do to get this even hotter? Well, a few things. We can launch stuff at it. strangely enough, that's not really having a big impact on the overall temperature. So let's do something like launch the moon at it. That changed the temperature a little bit. But oddly enough, is cooling it. What if we launched an Earth at it? Oh, now that heated it right up. 3,849 degrees Celsius. Yeah, that heated it right up. Let's see. Can we launch? See, there's no star we could launch at it that wouldn't just be equivalent to putting something in the star is going to be a whole lot bigger than anything we can throw at it. So now let's see here. Now that I've got it a little bit hotter, and by a little bit I mean massively hotter, let's start adding some more hydrogen, except instead of adding 1 moon per particle, we start adding 1 Earth per particle. Yeah, there we go. Okay. Now we have a mass of 2 Jupiters, 3 Jupiters. You know what? Let's just jump it up and start adding a Jupiter. Now every particle weighs 1 Jupiter. Okay? And our density is getting... It was high, but it's actually going down now. Ooh, okay. Okay, yeah, okay. That looks to me like... So that's 244 Jupiters. A density of 209 grams per cubic centimeter. I think we started fusion. That looks kind of like, to me, like a red-orange star. It's not super hot. Only 324. Pretty luminous. What happens if I double that? Oh. What happened? Did we go... Wait, what happened? Did we go Nova? What? Okay, hold on, wait. Time. Did we go Nova? Okay, let's fix this, hold on. That was quick if we did, man. Okay, we're gonna start with just some hydrogen this time. Oh, okay. Now let's keep throwing hydrogen at it. Okay, yeah, you can see it now getting brighter. See how once you add so much hydrogen, it stops mattering, because just the amount of hydrogen, it starts getting so dense. There we go, temperature's going up now. So it starts getting so dense, and you can see the color changing. So as it gets hotter, it goes from being red, orange colored towards a bluish white, and it goes through all the colors in the middle. So red is the coolest, and then blue, purple, white, those are the hottest. And you can see it getting more on that purplish white end of the spectrum as I add this crazy amount of hydrogen. So I want to point something out here. We have a mass of 1.08 suns, a density of 98,000 grams per centimeter cubed. So dense. 98 kilograms, 2.2 pounds per cubic centimeter. That's not much. So, you know, a kilogram is 2.2 pounds, 98 kilos. We might as well say are almost 220 pounds in a space that big. So that's pretty dense. And almost 6,000 degrees Celsius. So that's really hot. That is some oomph. So we don't really know though until we compare it to, and you can see it's a similar size to the sun. And I have to put the sun way out of way to keep it from just instantly getting sucked in. So the sun is only the sun's density is only 1 gram, 1.37 grams per centimeter cubed. And actually, it has a smaller radius than my new star I've made, which is odd. It's also, by the way, about 200 degrees Celsius cooler than my recently created star. But that's not good enough. That is not good enough. I want to start adding, well, no, let's keep it at Jupiter's for now. And let's make this boy a little bit bigger. Because see, the bigger that it gets, eventually these particles are going to have a lot less of an effect on it. And the math is not really making sense here in that, whoa. I think I just made a quasar. It's 769 Jupiters. The sun, yeah, I think I just made a quasar. The sun is got a tail now. Oh my gosh, that right there is something. Alright, but let's see if we can power it up a little more. Just throw some more hydrogen in there. See, now that it's this big, you're not seeing the effects as much. So I may have to up the amount of mass that I'm adding. Oh, yeah, that is a cool way to watch it. So you can just see this. It's like this, I know that looks like a little wimpy string, but that is a uber amount of hydrogen that's just being thrown at that. Oh wow. Okay, let's keep adding it. Come on, let's make this a strong boy. That is hot, dude. 52, but it looks actually like it's cooled down some. So it's time to stop playing. Every particle is one sun. That right there might blow this whole shebang up. 50 suns. The actual sun here is probably pretty close to being torn apart by this thing. I just want to point that out. So we're at 50 suns. We're about to get a lot more. Almost 600 suns now. And the temperature, though, is still not going up, which is kind of crazy. Let's get up to 1,000 suns, and then let's start adding some iron, some heavier metals. So now we're almost at 1,600 suns, and it's starting to flare out because of all that iron. Oh wow. Okay, the sun is still in one piece, though. So now what happens if we start throwing, you know, let's put this planet around and let's let it consume some planets. I don't know exactly what what's going to be the biggest here. Oh wow, that planet was bigger than Jupiter. So yeah, that, as you can see, oh my gosh, it just ate the sun. Oh my gosh. So that is a supernova right there. Earth is now 15 suns, but it's still super hot. And in here at the core, yeah, that we made a black hole. Oh, it's 15 suns, but it's only 44 kilometers across. Yeah, we made a black hole. And here, okay, whoa, wait a minute. There's a Jupiter. That now only weighs 10 Earths, but is 25,000 degrees Celsius and climbing, which is actually hotter than the Nova remnant. But this whole giant supernova, yeah, oh wow, a lot brighter than the sun, is about to hit 100 astronomical units, which is the distance from the Earth to the sun across. It has the mass of 1,500, almost 1,600 suns. So that's what happens if you were able to throw Jupiter's worth of hydrogen at the Earth over and over and over again until it eventually just exploded. And, well, actually, until the sun crashed into it and then it all just exploded. But we've not actually hit the biggest, baddest thing on the block, because for that we could add in a black hole, like, you know, like this. We could add in a couple of them, or we can add in a lot of them. We can add in some Sagittarius A's. Odd that it doesn't let you do your own. And then we can just crank up the time. And we'll open up. It's really freaking out our Sims. Oh wow. So the supernova is still expanding, and that's still 50, but man, it's doing a crazy light show. Oh, okay, so that's why. Yeah, I broke reality and pushed something to 62 times light speed. Good for us. All right. But that's about it for this really, really cool game. If you have any interest in space or astronomy or physics or anything, this is a cool thing to check out. I love it. But that'll be about it. So thank you for watching, spending your time here with me today. I really appreciate it. If you liked it, leave a like, leave a comment. If you really liked it, give that subscribe button just a little smooch, because it lets you see stuff like this all the time. And again, just thank you so much for being here, and I'll see you next time. Bye.